not moving. Is this screen visible?
Yes, sir.
Okay, so how many of you have seen this movie called Queen? Anyone has seen this movie or not? Hope everyone has seen this movie somewhere. So I think it's a 2014 movie. So it's all about typically a naive girl. So can anybody tell me who are the naive person? Can you Google it out for me? And also, can you find out who are the naive person? Who are so naive? You can put it in the chat box also. A person called naive. When we call a person naive,
So a person showing lack of interest, experience.
yeah, okay, great. A lack of experience in some field, maybe. So they are the naive person, right? Any other example of a naive person? Maybe you can call a naive person, maybe innocent person, right? So they are the naive person, right? So naive screen doesn't move sometimes. Okay. So naive person is someone with obviously those who lack some kind of experience. Maybe they show some kind of innocent behavior, a childish behavior, right? So those persons are called a naive person. Okay. So today's topic is all about your naive based classifier. So how naive based classifiers are used in machine learning techniques to classify. Okay. So typically we have covered, if you can recall, the first classifier I have used was the logistic regression. Then again, I covered this linear discriminant analysis where we typically reduce the dimensions as well as we done the job of this classification as well, right? So naive Bayes does the same thing, but their approach is different. But they are so innocent. I'll show you how this classification algorithm is innocent. So I'll demonstrate it. So we call it a naive because there is some kind of assumptions that will fall under a naive category, right? So why we call a naive, and there is one more term called Bayes, right? So we might have heard of this Bayes theorem, right? So typically in class 12th, you might have covered this Bayes theorem, probability of A slash B. There is one formula of Bayes theorem, right? If you know the probability of one of the event and you want to calculate the event of other, right? So that is typically used by the Bayes theorem, right? So naive is in this algorithm, we call it a naive because it makes some naive assumptions, right? So they think that there are some features which is independent of other features. But typically in real life, it doesn't happen. For example, if you want to predict the churn of let's say of employee from XYZ company, right? So it doesn't mean that there are some factors, for example, age, salary, their satisfaction levels. It will definitely affect the churn, right? So that is your target variable. So here in naive, base classifier, typically this algorithm assumes that each feature is independent of other features, but typically it doesn't happen in real life. Okay, that is one approach of this naive. Okay, and the base is obviously the Bayes theorem that I already told you that probability of A slash B. I'll show you what is Bayes theorem. So when you combine it, the both term, this naive and Bayes, then we call it a naive Bayes classifier. So typically I will be using this classification approach here, how you are going to classify and how if there is one new observations, then how you are going to put it into XYZ class. So I'll show you through this naive Bayes classifier. Okay. So naive-based algorithm is nothing, but it's a machine learning supervised classification technique. Okay, just remember that it's a supervised technique because there will be some features and target variable associated with it. Okay, with a strong independence assumptions between the features. Okay, so typically in naive-based, as I already said, that if we have, let's say, 10 features to predict churn of a customer, then all 10 features are assumed to be independent of each other in case of naive Bayes. It is mainly used for binary or multi-classification problem. Okay. Also, when you will work on any project, right? If you want to use this naive Bayes classifier, so if you have a multi-classification problem, then also you can use this naive Bayes classifier. Okay. And also naive-based classifiers are also used in text mining one. Okay. So, okay. So for example, a vegetable may be considered to be tomato if it is red, round and 2 inches in diameter. Okay, these are the some features. If these features matches with, then you can say it's a tomato. Otherwise, it could be other vegetables. A naive-based classifier considers each of these features to contribute independently to the probability. So that is why we typically go with this Bayes theorem, because ultimately we want to capture the probability of each features, how they are contributing towards the target variable, or you can say the prediction of a class. That is why we require Bayes theorem, right? So if you see the feature right side, the feature and target variable, this one is your typically one data set. So if you see this data set, feature and target, age, income, status is 3 features. And by is a target variable or class, you can say. By is a class. And there are 2 class, one is yes and no. Or also you can say the label or target is the same thing. Here label is a by. And there are 2 labels, yes and no. I mean, there are 2 class. So if age is less than 20, I'm just explaining the first observation. If age is less than 20 and income is low, if someone's age is less than 20 and their income is low, and he and she is a student, then there is high probability of buying, let's say, a computer. Okay. Similarly, you can go with the all data set. Okay. And this is a typically combination of input and output, because features and target are associated. Input and output are matched. That is why it is called supervised machine learning algorithm, because the data set is supervised, because corresponding to every single input there is one output. Had it been only features, we call it unsupervised data set. If we will remove this target variable from here, this data set will become unsupervised. We don't know if someone's age is less than 20, income is low, student, whether they will buy it or not. We don't have the target variable. Okay. So naive-based algorithm, as already said, will follow this strong independence of each features. For example, age is not affecting the income and income is not affecting the status. Similarly, status is not affecting, there is no effect on its income, and income has no effect on age or something like that. So there is no interaction, or all these 3 features are independent of each other. Okay. In case of naive-based classifier. Okay. Okay. So now coming to the second data set, let's say we have 10 customers, whether they own a house or not. Okay. Whether they own house or not, and their marital status, their income, and credit risk. Let's say this is the data set with one of the, you can say one of the banking company or insurance company. They have this data set. Okay. They have lakhs of records. Ultimately, we are showing only the 10 records here. If you see this data set here, homeowner, go with this feature, Yes, no, yes, no. This is a binary. Marital status is also a binary. Okay. Kind of a, you can say, yeah, kind of a, you can encode it, but it's not a binary. Married, single, divorce. There are three class, you can say. Here also in income, there are also, I think, three class, low, medium, and high. But in credit risk, if you see this credit risk is a target variable or class, okay, or also we call it a label sometime. There are two labels here, low and high, or also you can say there are two class. One is low, other one is high. Okay, so there are two class. So that is why this is supervised, or in night base also. Obviously, as I already said, homeowner doesn't have any effect on this marital status. Every single features are independent. There is a no, you can say, the interaction of all these features within each other. Okay, something like that. Okay. But if you see this target variable, we have low, high, and low, high. It means it's a binary classification. Okay. By looking at the data set, at least you can say we can apply this naive base, right? Also, you can apply here, you can say the logistic regression. Because whenever you see this binary classification problem, we have so many machine learning algorithms. But how we are going to compare that which algorithm is going to perform better? So you have to apply all three, four, whatever we learned here, we will apply in a single data set, and we will see how are all algorithms are performing on a single data set. If one of the algorithms has higher accuracy on data set, then we will say this algorithm, let's say if naive base is performing well in terms of accuracy. So we will say naive base has learned this data set well. I mean, this naive base is able to learn the pattern in the data set well. Obviously, their accuracy is higher, right? So depending on the kind of data set, the performance of machine learning algorithm will vary. Okay. So now coming to this naive base, this is a Bayes theorem. Okay. So coming to this Bayes theorem, probability of A slash B equal to probability of B slash A, and then probability of A divided by probability of B. This is called a Bayes theorem. Okay. We want to calculate the probability of B, probability of A if B is given, or something like that. Okay. So I'll explain you how. Now we want to calculate the probability of A slash B. This is a condition. Okay. This slash is a condition. Probability of B slash A. This is called a likelihood. Probability of A is called a prior probability, and probability of B typically called, we can also call it a normalizing constant, but sometimes it is also called a evidence. Okay. So in this Bayes theorem, because ultimately we want to calculate the features and how features are associated with each other, because there is some probability of the features and which are affecting on the, you can say, the target variable. That is why we are looking for this Bayes theorem. Okay. So now coming to this Bayes theorem, if you see this, how we are going to explain this Bayes theorem. Let's say probability of A slash B is called a posterior probability of class, let's say target given predictor attributes. Here's just see. This B is a predictor, or you can say the features, and A is a class. Okay. Class means whether you want to give loan to a person or not, whether someone will buy computer or not. Okay. Buy is a class, and the features B will be BX1, BX2, BX3. These are the features. Okay. So age, income, salary, based on those three features, whether a person is buying computer or not. Okay. PB is the prior probability of a class. Obviously, he or she will buy computer or not. Probability of B slash A is the likelihood, which is the probability of a predictor given class. Okay. And PA is the prior probability of a predictor. So don't get confused with these terms. I will be explaining you with one of the example, then you will understand. Okay. So typically, this Bayes theorem we will use to see the probability of different features if a class is given. Okay. So now coming to this, how we are going to build a Nye-based classifier. Okay. So whenever we are modeling any machine learning, you can say models, if our data set is given, okay, we are here talking about the numerical data set. Maybe we capture it in an Excel sheet where all the numerical data is there. Let's say for predicting a customer will churn from your company or not based on age, salary, their experience, maybe their certifications, maybe there are maybe many features, and based on those features, and we are trying to predict whether that person is going to churn from our company or not, right? If that data set is with us. So whenever we are building a Nye-based classifier ML model, we typically train a data set. If we have, let's say, 1000 records in an Excel sheet, so we will use 800, let's say, data points or observations or records for training our data, for training our model. Okay, that is why it is called training data. 800 records will be used for training our model. So that will be used for a Nye-based classifier ML model, and then we will have a new data. We call it a X here. New data means 200 records, 200 unseen data, 200 of, you can say, a new observations. Once our model is developed, we will fit in these 200 records, and we will try to check how they have performed, how they have learned, and what is their accuracy. Okay, that is called a classification reports, where we typically captures type 1, type 2 error. Okay, so the performance of this Nye-based classifier can be tested using this new data or unseen data points, because ultimately it's your final exam which are going to decide how much you have learned during all your semesters. Okay, so semester is kind of a training, and your final exam is a testing, and the test is score. Let's say you have got, let's say, 85%. It means you're well trained enough. Okay, so typically in this approach, the performance, or you can say the accuracy part, is going to tell how well your any ML algorithm has performed. Okay, so here I'll show you how Nye-based can be explained. Okay, if you have a new data points, and how you are going to calculate that a new data points will belong to class A or class B, whether a new you can say employee will churn or not, a new customer will buy, let's say, computer or not. In a banking industry, a new customer who has just come in, whether I should provide loan to that person or not. You can say the acceptance or rejection of a loan, right? So how we are going to illustrate that with example, right? Let me show you. So here, just see this example. X1 and X2 is the two features here. Let's say X1 is age and X2 is a salary. Based on these X1 and X2, let's say we have a 16 people, okay, age and salary. Okay, and this blue and this cross, you can say this yellow one, we are providing loan in this circle, and cross means we are not providing a loan, rejection of a loan based on age and salary. There are two classes here. Okay, let's say we have a 16 such customers, and when we plotted it out in a two-dimensional view, this is how it looks like. Okay, and if you see, there is clear separation. If you can draw it a line, it will show you a clear separation between these two classes. One is acceptance of a loan, let's say, and other one, this yellow one, is a rejection of a loan based on these two features, X1 and X2. But in Nye-based, we typically assume that X1 and X2 are independent. they are not affecting, let's say x1 and x2 are not affecting. Okay, so just see. Now let's say a new customer comes in an ICICI bank. So how, let's say, manager of that company, manager of that branch, let's say, will provide loan or not, whether he will accept or reject a loan. Okay, this is a case. This is this diamond, this black one is a new person. Now only the branch manager, let's say, knows his age and his salary. And this person, he is confused whether he should be given loan or not. Because there are two class only. Either he will give a loan or he will not, based on age and salary. Let's say, okay. So this is our case. Then how we are going to decide if we have to use only the naive Bayes approach. Okay. So now see. So we will calculate probability of A slash B. I'll explain you what is A and B here. Okay. So if you see this one, probability of CK slash X, this one, just see this one. X is typically a feature here. X is a feature, X1 and X2. We have to calculate the probability of, let's say, orange and blue. If I call it a blue, orange and blue, or yellow and blue, whatever. Let it, we just call it orange and blue. So probability of orange color if X1 and X2 is given. Now probability, we have to calculate probability of, let's say, orange, and probability of feature X1 and X2, age and salary, if orange, probability of orange is given, and also divided by probability of all the features X1 and X2. Okay, just see here, probability of this is probability of orange color if features are given. Similarly, probability of, we have to calculate probability of orange and probability of this blue color. Similarly, if probability of this one is given, then probability of orange, what is probability of orange, and probability of these features. So typically we will capture it, because what is probability of orange and blue, right here? So what is probability of orange here? Because there are 2, 4, there are 8 points, and here also there are 8 points. Okay, so when we calculate the probability of orange here, it will be number of orange points divided by total number of points. So there are 16 points, and out of those 16 points, there are 8 orange points. So 8 divided by 16 is 0.5. So probability of orange in this class is 50%. Obviously, using this out of 16, the probability of this blue color is also 0.5, and probability of this orange color is also 0.5. Okay, so we are just calculating probability of the class. Orange is one class and this blue is another class. Okay, so the probability of orange class is 50% here. Now in this is a new data here. Okay, unseen customers. So whether he will belong to this blue class or orange class, this is our case, and we are just trying to find it out. Okay, now in this case, just see, we have just removed this unseen, a new customer here. Just we have encircled it. Okay, so now probability of features. So number of similar observation divided by total number of points. So if you see the neighborhood of this unseen customer, neighborhood of this, when you encircle it, there are 3 points, 1, 2, and 3. Okay, there are 3 points, and total observations was 16. So probability of this new data points was, the near to that data points was 0.18. Okay, so probability of X slash orange. So oranges in a circle, how many oranges are there in a circle is 1, and total number of, you can say, the orange points are 8. So P of X slash C orange is equal to 1 by 8. Okay, this is your probability of orange color if features are given, okay, is 0.125. Okay, so now ultimately we have calculated probability of orange if X means unseen data points. So it will be, the probability will be 0.33%. It means the chances of keeping unseen data points in orange class is 0.33%. Okay. Similarly, if you calculate the probability of blue for unseen data set, it will be 0.67. It means unseen data or unseen customer must belong to this blue class. It means if a bank manager knows age of a new customer and salary, then he can easily decide whether he will go to this orange class or blue class. Okay, so here through this illustration we come to know that he will definitely go to this blue class. So here we are providing the loan to that person here. Okay, so this is a knife based approach using the probability. Ultimately we are capturing the, you can say, the features, those two features and the class, also while calculating this knife based approach, because it's a more of a probabilistic approach here. So this is how for our new customers we can decide he will belong to this, let's say, acceptance of a loan or rejection of a loan here. So here we have seen that he or she will belong to this blue class. It means manager is going to approve his or her loan, right? So this is how we can illustrate this knife based approach. Okay, so here this is just an extension of your previous whatever I have explained, because probability of blue is higher and probability of orange is low. So obviously a new, this one will belong to here. Typically they have just put it a blue color here in place of this triangle color. Okay, so this one, if you see this one, this is also I have just explained you in the previous the slide. So for example, this is just a summary of how we are going to predict a new customers whether he will belong to this orange or blue class. So for example, what I did was probability of orange when test data was given. Test means unseen data, a new customers. So I have calculated the probability of orange, okay, and probability of this test data. What will be the probability of test data? So if you will calculate the probability of test data, it will be 3/16, and probability of orange is 8/16. Okay, and probability of test data slash orange is 1/8. When you put in all these things here, we will get 0.33. The probability of test data belonging to orange class. What will be the probability of unseen customers belonging to orange class, whether he will be accepted? Let's say orange is a denial of a loan. So probability of unseen or a new customers, he or she will belong to orange class is 0.33%, means 33% here. But probability of the new customers, he or she will belong to blue class is 67%. So obviously bank manager will put into this blue class here. So this is a simple summary. If you haven't got it, you can easily scroll through and you will get to know how I have calculated it. It's just a summary. Okay, so a new customer will belong to this blue or orange class if a test data is given or unseen customer is given. Okay, so now so obviously the probability of this blue class is higher, so that is why we will put in into this blue class here. So this is a typical, you can say, the explanation of how prediction can be done for a unseen customers or a new customer or for a test data. Okay, so coming to this Python programming, let me show you how you can do Python programming. So I think in is my screen visible? Is it visible? Can anybody confirm if it is visible?
No, sir.
My screen is not visible. 1 minute. If it is visible
now.
Okay. 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 So if you see this one, so import numpy as an np, I think you know it for multi-dimensional array because data points is captured in an array. And for importing data set, because ultimately I am importing data set from this location. So that is why import panda as pt, and matplotlib by .pyplot is for your data visualization. Here I haven't used it any, visualization. So you can put it here. Okay, so when you run it, so data set equal to pd.read. I think you all know how to import the data set, the location of this data set. I think I have used the same data set, and in this data set, employed, bank balance, annual salary, whether he will default or not. This is a defaulted is a class here, and all these three are features. Okay, based on these three features, we are come to know that whether he will default or not, right? And these three are your X equal to your features, employed, bank balance, and annual salary. Three features and one your target variable. Y is your target variable. Okay, that is why input and output combination is here. Okay, so now in this one, if you split this data set, okay, now you can see here you can split it from sklearn.model selection import train test split. We are trying to split this data set. Let's say test data set is 20%, training is 80%, and test is 20%. Means out of 1,800 is used for training the model and 200 is used for testing. Okay, and random state means here someone has, I think, asked me this random state. It means for testing data they can randomly select from anywhere, but here we are saying random state is equal to 0, they can select it from anywhere. Okay, now there is something called feature scaling. I think I have explained you already what is feature scaling, because if you see why we typically scale the features, because if you see the bank balance, it's in 4-5 digit. Also, and salary maybe in 6 or 7 digit, because they are in the two different range. So to make it in a single range, we have to scale it. Okay, because once you scale it, the processing, you can say the speed of execution will be higher. From S, my screen is not visible.
Sir, it is visible.
1 minute. This screen is visible. This Python. 1 minute. Python one. Just
Yes,
confirm it.
sir.
Okay.
Sir, Jupyter notebook screen.
Yeah, good. Okay, so coming to this in 8 from sklearn.naive base, this one. Okay, this one is a naive base. We are importing from Gaussian naive base. So I am just implementing Gaussian naive base. There are different methods. One is Bernoulli's theorem. One is Gaussian, and there is also multi model or something. Okay, so we are typically implementing this Gaussian naive base because we assume that every feature will follow a Gaussian distribution here. That is why Gaussian NB, naive Bayes. Okay. GNB is your user defined, you can put it anything, and Gaussian NB. So here we are training our model. We are just building our naive Bayes model here. That is why we are just using this Gaussian NB function. And now we are fitting model. So once you fit a model, obviously for fitting a model, we pass two parameters, you can say. One is X train and Y train, because ultimately we are training our model. Here in this, we are training our model. Our training Gaussian model, or you can say we are training naive Bayes model here, naive Bayes classifier here. So once you run it, now once using this training data set, our model is trained here, because X train and Y train has used 80% of the data and 20% is I will be using for testing. Okay. So now coming to this, I think for making predictions. So in making prediction, we are passing X test, means 20% of the data in any sequence. That is why random state is 0. It can take in any sequence to testing. Okay. So now 20% data is used for testing. And then coming to this confusion matrix. So coming to this confusion matrix, from sklearn.matrix, import confusion matrix. And here we are passing test data and trying to predict it, how they are deviating from the actual. So that is why whatever we have tested and whatever was actual in our Excel sheet, we will compare it. That is why it is called a confusion matrix, because there will be a lot of confusions. Because actually there was something and your model is predicting something. That is why it's a more of a confusion matrix. Okay. Now coming to accuracy, its accuracy is 96%. It's a good model ultimately, because accuracy is 96%. Typically in normal life, or in, you can say, in practical application, you will not be getting this kind of accuracy, but the data set is highly supervised, you can say. So it's giving you 96% of accuracy. Now coming to this one, just see this one. This confusion matrix, you have predicted 199, just see this one, 1911 number of records or number of observations correctly. Because actually in your Excel sheet, actually it was no class, he wasn't defaulted. Defaulted is no here, no default, because class name is default and there are two class label, one is no and was yes. Means a person, there was 1911 number of persons who wasn't defaulted, and also our model has predicted that he didn't defaulted. So it means it's a good. And this one 18. So our model has predicted, yes, he defaulted, he will default. And also in our Excel sheet, it was given in our data set that yes, he is going to default. So this, you can say 1911 and 18. These are the correct predictions. But 15 and 56 is a problem for us. If we are in a banking industry, now we have to decide what to do with 56 and 15, because we have predicted this person is going to default, let's say, but actually he didn't defaulted. Okay, so 15 is not a problem, because we have predicted that this 15 customer is going to default, but actually he didn't defaulted. So it's not a problem. But the problem is here 56. We have predicted that he or she is not gonna default, but actually he defaulted. So just think in terms of a financial industry, you have given loan to 56 persons and he taken your money away from the bank. Just imagine it. It's not like 1,000 rupees or something. It's in crores, millions of a dollar, right? So it's a problem for us. 56 is a problem for us. This is a type 1 error. Depending on industry, the type 1 and type 2 error, you have to reduce it. So there are different methods. There is something called hyperparameter tuning. I will not be explaining it, but maybe in subsequent class, I mean, people are going to teach you this hyperparameter tuning. How using this hyperparameter tuning, how you are going to reduce this type 1 error. How you are going to reduce this maybe 56 to 40, maybe 30 or something like that. Because ultimately this 56 is a problematic for us, because the person you predicted that he is not gonna default, but actually he is defaulting. This is a problem, right? So typically, not only you apply the machine learning algorithm, but also try to understand in a try to interpret it in a real sense, that what these data points are saying. Okay, so this is your naive based approach. So okay, is this screen visible? Just confirm once.
Yes, sir.
Thank you. So in Python programming, I think just I have used this this is screenshot so that you can understand that these data sets, there are 5 records using this head command. I have printed it. Okay. So you know it, this employed, bank balance, annual salary, these are the features, and default is your class or target variable. Okay. And these are some splitting your data set, then scaling it, then training your, you can say, the naive based model. Once you have trained it, now you're trying to predict for unseen data. X test is your unseen data, and then you have developed this confusion matrix, and you have checked this accuracy. Accuracy is 96%. Okay, and ultimately this is are your confusion matrix. And this 56 is type 1 error, because it's a banking industry. 56 is problematic for us. Okay, so how we are going to reduce it, maybe you will get to know in your hyperparameter tuning, how you're going to reduce this type 1 and type 2 error also. Okay, so how different ML models are hyper tuned so that type 1 error can be reduced. Okay, so here I am just showing you only this much. Okay, so this confusion matrix, and then I'm not showing you hyperparameter, but I will be sharing you so you can see hyperparameter and all. But coming to this, some challenges of this naive base. What are the challenges? Because ultimately we are, as there are some assumptions, so for every models there are some challenges. Okay, so the important notes on this 1 minute. Yeah, if continuous features do not have normal distributions, okay, we should use transformation or different methods to convert it into normal distribution. So that is why sometime, if our features are given, for example, age and salary, age in typically in 2 numbers, you can say, and 2 digits, but salary might be in 6 or 7 digits, possibly. Okay, so we typically use this feature transformation, or we say it, feature scaling, normalization, and standardization, so that they follow these normal distributions. Their mean value will lie somewhere, mean and standard deviation. Okay, for a standard normal distributed data, the mean is 0 and standard deviation is 1. So in this naive base, we have to remove correlated features, and highly correlated features are voted twice in a model, and it can lead to overinflating importance. Okay, so also you have to check if there are some features which are redundant. Typically we have to remove it. Okay, so coming to this, some challenges. So assumptions of this, independent features. So typically in naive base, as I already said, we are saying the independent features. Features are independent. We assume that each features are independent. But in practical, it's almost impossible. That model will get a set of predictors. Predictor means features which are entirely independent. It's not possible in case of if you do any, you can say enterprise level machine learning, model building, then you will come to know that there is no such thing where there is some features are maybe some features are independent, but not all the features. But here in naive base, we typically assume that the all the features are independent. Okay, so these are the some challenges. If there is a no training tuple of a particular class, this causes zero posterior probability. In this case, the model is unable to make predictions. This problem is known as zero probability frequency problem. Okay, so if there is a no training of a particular class, maybe there is something called class imbalance problem. Class imbalance means, let's say, out of 1000 data set, if there are two class, let's say 0 and 1, let's say buying a laptop and not buying, churning of a customer, churn or not churn. Okay, there are two class. And there are, let's say, out of 100 data points, 800 classes are of one class and 200 are of some other class. So in that case, it will create a problem that is called a class imbalanced problem. For training your any ML model, you must have 60-40 ratio. If one class is 60%, other class at least should be 40%, and try making it at least to 50-50%. Okay, that is called a class imbalance problem. Okay, so what are the advantages of this naive based classifier? Ultimately, apart from the disadvantage, there are some advantages of this naive base. So when we typically use this naive base approach, right? So this works quickly and can save a lot of time, because this is based on, you can say, the probabilistic approach. So if we have limited time, limited resource, in that case, we will go and run this naive Bayes classifier on our data set because it works quickly, right? And also naive Bayes is suitable for multi-class prediction problem. If you have a more than two class, you can say. So in that case, also you can take help of this naive Bayes approach, okay, at that time. If its assumptions of independence of features hold true, it can perform better than other models and require much less training data. For example, if there is some industry, let's say it's a healthcare industry, where there may be possible that there are different features or factors which are independent. Maybe in financial, you can say, industry, there are some factors, or you can say the features, which are independent typically. If it is really independent, then your naive Bayes can do wonders. Okay, naive Bayes is better suited for categorical input variables. This is important one. Here it is saying, if we have categorical input variables, it means if you have a lot of categorical features, and target is typically obviously your categorical, but if you have a lot of variables, you can say the features which are categorical in nature, in that case you will use this naive Bayes. It's a good one. Okay, now there are some disadvantages, because ultimately naive Bayes assume that all features are independent, right? But rarely it happens in a real life. So this is one of the disadvantages. So obviously, even if your model performs well, but in testing case, it will fail miserably. Okay, so that is why in that case, better not to use this naive Bayes approach. Okay, if your data set is more sensitive, so don't use naive Bayes approach. The algorithms require smoothing to face issues arising due to the presence of features in the testing data that were absent in the training data. Okay, so maybe you have to normalize the data, standardize the data, so that you can get good accuracy and all. Okay, the algorithms can give wrong estimations. Naive Bayes assume features to contribute independently to the probability of occurrence
Hello, sir, are you there? You're not audible.
I think he got disconnected. He will be joining back in a minute.
Okay, sir.
Yeah, hello. Am I audible?
Yes, sir.
Let me connect through my laptop. Just give me 2 minutes, okay?
Sure, sir, sure, no problem.
Screen visible, right?
Yes, sir, it is visible.
Is my screen not waste much of the time? Okay. So there are some applications of this knife base. So just so to see this application, because I'm just stressing on this application part, because ultimately you have to do some project part. So if you see this one, if you want to build any real-time prediction model, you can also use this knife base. If you want to filter out some spam mail, right, you can work on spam filtering, or you can apply this knife base, and also for sentiment analysis if you are interested in text data, or you can pick up Amazon text review or somewhere. Okay. And multi-class predictions if you have more than 2 class. Text classification, obviously sentiment analysis and text classifications are more of a similar approach. They use similar approach. And there is something called recommendation systems design. Okay. So sentiment analysis, text classification, somehow they are also linked with this recommendation systems design. Okay, so they also use support vector machine, but also you can use this knife based approach. So just see, screen is not.
Hello, sir. You're not audible.
Yeah, one. Yeah, actually my screen is not moving today. I don't know
Okay.
where I stuck. Just if if failure happens, it happens at multiple level, right? Sometime. Okay, now it is moving. So okay, so as I already said, there is something called text classification. Okay, just see quickly. I think you people can easily relate with this text classification. So let's see if you have a document. Okay, if you have a, let's say, maybe if you have some document of, let's say, 10, 12 pages, right? And you want to know whether this text belong to some, whether they are talking about the art, business, culture, entertainment, what they are talking about. You want to just, just model it, the topic. There's something called topic modeling, right? So typically how they do this text classification, right? For example, on the right side, just see, you from Amazon, let's say, or some from any review platform, you just picked up, let's say, 8 to 10, you can say, this comments. Okay, for example, simply loved it. Okay, so this obviously will go to the positive class. The label is positive because they are talking some positive, right? Most disgusting food I ever had. Let's say this is a Zomato platforms, their review, right? So it's a negative one. This is a good restaurant. It's a positive one. This place had best food. We have labeled it a positive. So typically how knife based approach can be used. So for training example, let's say there are the 10 records. We have just labeled it corresponding to every single, comment. You just labeled it, whether it's a positive comment or negative comment. This is a training. Once you train the model, then let's say, for example, if there is some unseen comment, so this unseen comment will be classified into maybe the positive, negative, depending on how well your knife based model has trained, how they have trained enough. Okay, so this is how text classification typically works. Okay, now you want to filter it. Okay, email, you want to filter whether emails which you have received is a spam or not. I think you all know it because from the IT background, you might be knowing how we typically get to know that whether an email is a spam or not. So if there is some mail is a spam, so we just label it, it's a spam by looking at some words. Okay. So this is one approach. Yeah, knife base can be used. Yeah. So Then there is something called sentiment analysis. I think you might be knowing this word, sentiment analysis, a lot of time, because in social media, maybe in e-commerce platform, Amazon, maybe everywhere where there is interaction of, customers, we talk of this sentiment. Maybe you might have heard of this in election campaign also. Yeah, NLP. In election campaign, I think in 2014 or previously, maybe this government has used this sentiment analysis also from maybe the social data, okay, social media data. They have used a lot of social media's data. Maybe you might have heard of this Cambridge Analytica case also, okay. So sentiment analysis works well sometimes, but it's not like it will work in a real sense. But how we are going to get to know that the content, or you can say the sentence, has some sentiment, whether it carries positive polarity or negative polarity. Okay, for example, on the right side, just see Trump will lose. Obviously, the polarity of this sentence is negative. So in sentiment analysis, we work on negative, positive, and neutral polarity of the sentence. So typically in R or Python, when you feed a sentence, it will capture positive, how much it carries positive sentiment, how much it carries negative, and how much it carries positive. They just add it together and they calculate, okay, fine, it's a positive by looking at the threshold value. Trump is a liar, it's a negative, it carries negative sentiment. Biden, amazing Biden, right? It's a positive. So we typically train our, this, you can say, label it, whatever sentences we have, just we label it for training purposes, because ultimately you have to train our model. So that is why sentiment analysis can be used in this naive-based approach if you have to apply machine learning algorithm, one of the machine learning algorithm for sentiment analysis. Also, this is also comes in natural language processing. Okay, people who are working in this natural language processing, they do a lot of this sentiment analysis and all. Okay, real time prediction, you have to predict it real time. Okay, for example, Google Map and all, they also use this naive-based approach. They give you, shortest path. So they use a lot of algorithms all together, and then they give you shortest path, okay, or something like that. So real-time prediction is one of the good, you can say, applications in naive Bayes. So naive Bayes can be applied for real-time prediction as well. Okay. So these are the some, you can say, applications. Also, there is one more application called multi-class prediction. For example, if this blue and this red one is, let's say, churn and not churn. For example, if we have to classify 3 customers, low, medium, and high income group. Let's say there are 3 customers based on, let's say, age and income. We have to classify it. Let's say we have to club it into 3 classes. So naive-based approach can be helpful in classifying all these 3 classes. So this is a multi-class. This one is a multi-class. Okay. So one is face detection and face recognition. Can anybody tell me what is the difference between face detection and face recognition? Detection and recognitions. If anybody knows, you can type it, or also you can speak. So face detection and face recognitions.
So detection is just finding the faces in an images, and recognition is recognizing the person.
Yeah, right. Absolutely right. Face detection means, yeah. Recognition is one. Someone has written something. See. Okay. So fine. So face detection, as you already said, it's a more of a detecting of face, right? So this one, this triangle, okay, will capture the features. Okay, it is detecting. If anybody knows the the computer vision, they try to capture the boundaries. They capture the boundaries. Okay, so these boundaries, they are going to capture it. Okay, they are just saying this is a face first. Okay, so this is kind of a training. When you are recognizing a face, it means we are labeling it. The word leveling is important. We are saying she's a Maria Wood and has age of 30 and she's a female, right? So we are leveling it. So ultimately we are recognizing, means we are leveling this data. I mean this a person, if this obviously we are labeling this person. Okay, so detection and recognitions, these are the two different words. If you know this computer vision, then you can easily relate with this. Okay, so knife based approach can be used also. Okay, so this is all knife based. So let me quickly go to k nearest classifier. 1 minute. Yeah, recognition is telling the difference between the faces. Yeah, right. So one, two, just confirm if my screen is visible. Just confirm it. Is it visible?
Yes, sir, it is visible.
Thank you. Thank you. So let me quickly go. Okay. So when it comes to this KNN, that is called K nearest neighbor. Okay. So K nearest neighbor. I mean, uh, everybody likes to live with a good neighbor, right? We have a tendency to live with a person to whom we admire, or maybe for example, if people who are engineers, they like to live with engineers. Those who are doctors, they like to live with doctors. Maybe they have some kind of, you can say, affinity towards that category or that class. Okay, but looking at this poster, if you see this movie poster, uh, it's saying the good neighbor, but looking at this poster, it is more of a bad neighbor, right? But I'm talking about the good neighbor here. Okay, so we will talk about this K nearest neighbor. K means maybe it's a numbers. I'll let you know what is K here. Nearest neighbor. We like to live to those nearest neighbor to whom we love, right? So those who have a more affinity, maybe we will try to belong to that class, right? So coming to this K nearest neighbor, okay. So what is K nearest neighbor? So KNN is one of the simplest, you can say, the classification algorithms, and it is, you can say, the most used 1 minute learning algorithm. KNN falls under supervised learning family, and informally this means that we are given a labeled data set consisting of training observations. Typically in every single machine learning algorithms, we provide these training observations, or we can say the training data set ultimately, right? And would like to capture the relationship between X and Y more informally. Our goal is to learn our functions X implies to Y, so that given unseen observations, let's say if you have some unseen data points, so how, where that data points will fall, right? So I'll show you example also, so don't worry. KNN is a simple algorithm that stores all available cases, right? So typically what KNN does is, in the training data set, once you provide the training data set, they typically memorize the, the observations, you can say, the training observations. So they typically work on rote learning, right? Ratta marna, right? So once you train this model, they're gonna do rote learning, ROTE, rote learning, right? And based on these similarity measures, maybe in the clustering, you might have heard of some distances. There is something called Manhattan distance, Euclidean distance, Minkowski distance. There are many distances. So also K nearest neighbor algorithm will use some distance measure. They will use some distance functions to club, or you can say to predict how unseen data point will belong to, where it will belong, whether it will belong to class A or B, but they will use these similarity measures to predict, right? So KNN obviously is the old algorithm, okay? As I already said, maybe KNN is also a non-parametric and instance-based learning. I'll explain you what is instance-based learning. And also it is written KNN is a lazy algorithm, okay? Maybe in a lot of interview, people are asked why KNN is a lazy algorithm. Because it is lazy because it doesn't want to go beyond their boundaries. They just do a rote learning. Whenever you provide a training data set, their ultimate approach is to learn the training records. They don't go beyond their, you can say, their own territory, right? So they are so lazy. So sometimes KNN is also called lazy algorithm. Okay? KNN algorithm is based on feature similarity. If, let's say, if you have a friends who have a similar, you can say, personality, maybe similar liking, disliking, you like to go along with that, friends. Okay. So KNN is based on similar feature similarity. How closely out of sample feature resembles our training set determines how we classify a given data points. Okay. Just see if my screen is not visible, moving. Okay, now it is moving. Okay. So as I already said, KNN is instance based classifier. They typically use this instance. Okay. So just see, there are different attributes, attribute 1, 2, 3, and something like that. Let's say we have n attributes, and based on those n attributes, we are classifying whether this observation will go in class A, class B, or class C. Okay. And let's say there are some unseen cases, and we want to predict on which class ABC this unseen case will belong, right? So instance based classifier, we typically store, or KNN typically store all the training records and use training records to predict the class level of unseen classes. So they just typically use these instances, means all the records. Based on instances means observations. Based on the training records, they see how close unseen data points are. If unseen data points are close to class B, then KNN will predict that unseen data should belong to class B only. Okay, so this is you can say the crux of this KNN. For example, the basic idea of this k nearest neighbor, as I already said, and you can easily figure out in k nearest neighbor classifier. For example, we have this training records, let's say. Okay? There are duck, hens, there are many, you can say, birds here. Okay. So if it, let's say training records, and this is a test record here. Okay? This duck is a test record. And we have different, you can say, animals, or maybe you can say birds are here. Okay. So this test record should belong to this class, this class, this class, this class, or this class. This is our case. Okay. So if let's say if this test record walks like a duck, then it is probably a duck, because they have similar features, walking, quacking, or something. Okay. So that is why we are saying, because this test record is also exhibiting the same features, then it should belong to this duck class. So it means if unseen data points showing these features, similar features, then a new observation will belong to that class. That's all. Using the distance measure, I'll show you how. So instance-based classifier are also called rote learner, means ratta marna. It memorizes entire training data. This is a you can say the clue of k nearest neighbor. Sometime you will see there are some students, or maybe in I also have seen some students, they typically memorize every single question papers. So whenever they see any test paper, they just write it. It's kind of a rote learner, right? So KNN memorizes entire training data set and performs the classification. Means whenever they see a new data, a new unseen data, you can say, they just check with this data set, whatever they have memorized it. And based on this, their memory, they predict it whether they should classify them, predict them to class A, B, C, whatever class. Okay. Only if attributes of record match one of the training example. So whenever you provide a new data, unseen data, they match with the memorized training data and then they classify it. So nearest neighbor, this k closest point, the neighbors for performing classification. So I'll explain you what is k and why it is significant in k nearest neighbor. So for example, this is unknown record. And there are two classes, negative and positive. So this new class should belong to this negative or positive class. This is our case. Okay. So it requires three things. First, KNN requires three things. First, they must have set of a training records. They will use distance metrics to compute distance between the records. Obviously, this unseen data is how far from this positive class and how far from negative class. If this new record is nearest to negative class, then they will KNN will classify as a negative class, otherwise positive class. The value of k, the number of nearest neighbor to retrieve, means how it should be, it should capture a 5 neighbor, 6 neighbor, 7 neighbor. That is a nearest neighbor, you can say. Okay. So this is the nearest neighbor, the value of k. To classify unknown records, what they require, compute distance to other training records, means they will see how far from this positive, how from this negative. Okay, so they will compute it, identify k nearest neighbor. It should be, let's say, they should capture 5 nearest class, 6, 7 or 8, something like that, and use class level of nearest neighbor to determine the class level of unknown records. If, let's say, this red class is nearer to positive 1, then it should be classified as a positive class level. Okay, so this is what these all are. You have to follow this approach to predict new records to belong to class, let's say, positive or negative. Okay. So k nearest neighbor, let's say, for this cross is an unknown data points. So one nearest neighbor, if you encircle it, there is only one neighbor of this unseen data here. Okay. If you see unseen data, this is unseen data. There are two classes, negative and positive. So that is why this unseen record has two neighbor. One is negative and positive. That is why two nearest neighbor. So k will be 2, here k will be 1. Here for unseen data, just see positive, positive and negative. This unseen record is surrounded by 3 class. I mean 2 positive class and 1 negative class. So that is why they have 3 neighbor. So whether this unseen record should belong to this positive or negative, how far they are. Obviously, by looking at this, this visual, we can easily say this unseen record, this cross one is nearest to this negative one. So KNN will predict it to be negative class. Okay. So KNN classification, for example, based on age and loan. Based on age and loan, we are classifying it a person to be defaulter and non-defaulters. Let's say it's an unknown customer here. This green one is an unknown customer. Now just see how KNN is calculated. So this unknown customer, KNN will see how far is from this positive class, negative class, negative class, and this one. If KNN is, let's say 1, 2, 3, and 4, this will encircle it, okay? And then they will see how far is from this this red one and this blue one, let's say. By looking at this data set, if you see, this unseen record or unseen customer is closer to this blue one. Just see the distance one. That is why this unseen customer will belong to this non-defaulter class. Okay, this is how KNN works based on distance measure. Okay, how far a new or unseen data point is from your two classes. The nearest neighbor, how far is from their nearest neighbor. If it is closer to this blue nearest neighbor, then they will classify it to a blue class. Okay. So choosing the value of k, now it depends on how you are going to choose the value of k, because if you choose k to be a small, then it will create a problem because it will be sensitive to some noise points. Okay, so you have to smart enough in choosing this k value. This is also called a hyperparameter in KNN, the value of k. If k is too large, neighborhood may include points from other classes also. Okay, let's say if you see this is unknown class, this is positive class, and this is negative. There are many. Okay, so you have to be smart enough in choosing the value of k. It should not be too small and it should not be too large. Okay, just see here. There are two features, x1 and x2. Let's say age, x2 is age and x1 is salary. Based on this age and salary, we are saying we are classifying a person, let's say, into two classes, class A or B. Let's say if age is, let's say, 40 and salary is, let's say, 50,000, then he belong to class B, let's say. This is how you can interpret. Okay. So now this is unseen customer, you can say. So where it will belong? So if k is equal to 3, we are choosing 3 neighbors of this unseen records or unseen customer. There is a 2 class and 1 class. There is 3 neighbors. Now k is equal to 6 means we are choosing 6 neighbors. 1, 2, 3, 4, 5, and 6. And now we will compute the distance from each neighbors, how far they are. And then you will see the minimum distance. If you see this one, the distance of this unseen customer is closer to this class B. So obviously by looking at this visual, you can say it will belong to class B. But naturally it doesn't happen. You have to calculate it. Okay. So nearest neighbor classification, there is also some issue of scaling. You have to scale the data set. For example, when you apply this k nearest neighbor, so before applying any ML model or KNN, you can say you have to scale the features. Attributes may have to scale to prevent distance measures, because maybe if there is age and salary in a feature, so age is typically 2 digit and salary maybe 6 to 7 digit. If you have to calculate the distance, right, you will struggle. So that is why you have to standardize it and normalize it so that the value should be in between 0 to 1. So when you apply KNN, then it will work well. Okay, because distance can be calculated easily. The one factor is not gonna dominate the other factors. One features may not dominate the other features. For example, age and salary, because the age is 2 digit and salary is 6, 7 digit. So obviously salary will dominate over age, right? So that is why we have to scale it. KNN is called lazy learners because the reasons are here. Because it does not build model explicitly. Right? Don't any kind of, you can say, machine learning, there is no learning in KNN. Okay? Because they are not building any such models. Just they compare it. If you throw any unseen data points, they will just compare it with this training data set only, because they have just memorized it. They just pick up from the memory and they just say you that, okay, it will belong to class B or class A based on the memory only. Okay. Unlike eager learners such as decision tree, induction, and rule-based systems, it is not like that. And classifying unknown records are relatively expensive in KNN. The reason is that because they every time they compare it with every single records. If let's say K equal to 1000, then they will have to compare it with so many classes, class A and class B if there are two classes, because every time they have to compare it. They have to calculate the distance, and calculating the distance is obviously an expensive task. Okay. So, for example, just to show you this example here, I'll just take 5-10 minutes and then we will close. Let's say there is a training instance. There are 4 records, and there are 2 features, and this is a target output 0, 0 and 1, 1. Okay. This is our training data set. Just see x1 and x2 are 2 features, and output, this is a target variable. Now this is similar one. Now for example, there is a 3,6, there is a 1 point here, 3,7. Okay, 3,7. So 3,7 should belong to class 0 or class 1. This is our case here. Okay, and now it is saying that we have to pick k equal to 3. We have to go with the 3 neighbors. How we are going to predict whether this 3,7, if age and salary, let's say, not age and salary, maybe some other features you can say, 3,7, if a new unseen customer, let's say, has a feature of, let's say, 3 and 7, he should belong to class 0 or 1. Then we have to calculate the distance. This is how we have to calculate the distance. Okay, 7,3, because 3,7 we have to calculate 3 and 7. That is why 3 and 7 we have to minus it, because we have to calculate the distance from that 3,7 of each points. Okay, so once you calculate the distance, then you rank it 3, 4, 1 and 2. So 3,4 means 1. That is why 3,7 should also belong to class 1, because this is the nearest neighbor. Okay, so if we solve it through Euclidean distance, it is a similar one. Okay, so this is a similar one. As I already said, 4, 5, 3, 6. This is a distance measures typically, and we have to square it up. Okay, it's a similar one. Okay, the previous example, but their method is different. They use this majority voting and all. Ultimately, if you see, it will belong to class 1 only. Okay, so if you see, they will belong to class 1 only. Okay, so the nearest neighbor is used through this distance measure. Okay, so Python, quickly let me show you this Python. K nearest neighbor. So if you see this KNN, just it's similar to knife base also. So KNN, we will use the same approach. Data set, you have already seen it, and the feature and target selection is there. Okay, feature and target. Now we have scaled it, because ultimately, because we have to calculate the distance, so one feature must not dominate the other feature. That is why here we have just scaled the features, and here we are saying scalar neighbors and k nearest neighbor classifier. You are just importing here. Okay, and here we are just initializing the KNN model, and we are saying just use 5 neighbors here, and the distance measure is Minkowski distance. Okay, and this is some kind of a probability. Okay. So KNN.fit, we are just fitting this k nearest neighbor model, because once you fit a model, then you pass only this training data set. Okay. This is a feature, and Y train is your target corresponding to target. Okay. Then k nearest neighbor, once k nearest neighbor is fitted, then we have to predict it. Okay. Just see. We have just predicted it using this X test, whatever there in the X test. Let's say 20% data was there in the testing data. Now there is a confusion matrix, and their accuracy is 96%, similar to naive Bayes. And just see this confusion matrix if it is there or not. Yeah. If you see this confusion matrix, just see. So in confusion matrix also, KNN has performed well you can say better than this naive Bayes, because 51 was there in the class 1, you can say type 1 error in naive Bayes. But in KNN, it is 50. So it's almost a better performer here. Okay. But still, it is a problem for us. Okay. How to reduce this 51? Okay. This is a case. So we will use this hyperparameter tuning. Okay. In subsequent class, you will get to know how hyperparameter tunings are used. Okay? So this is how you can apply this KNN also. You can see. Okay, KNN. So typically step 1, you have this data processing, in which I have already shown you the feature and target selection is there. We select target as well as feature, and then we fit KNN model. Okay. Yeah, KNN model. Then we predict it, and then we see the confusion matrix and accuracy key, that how well our model has predicted well or not. How many type 1 error and how many type 2 errors are there. Okay. So these are hyperparameter. This is not required for you, but you can see how well or how poorly sometimes hyperparameter also doesn't work. So you have to check. Okay. So there are some pros and cons of this, you can say KNN. As KNN sometime, because it uses it's a rote learner, and also they use distance measures. So there are some problem. But KNN is a non-parametric algorithm and does not require any assumptions on the data distribution. Okay. So it's a good because it doesn't assume that the data should be normally distributed or not. So this is one good way. And also, it's very easy to explain because it's explainable. KNN is easily explainable. Okay, so that is why these are some good points of KNN. And KNN can be used for regression and as well as classification. Okay, if you have a problem of regression and classification, then you can use KNN. Okay, and KNN does not have any explicit training step. Okay, every time they compare it with this data set. Okay, training data set. So these are some, you can say, the pros of this KNN, but still there are some problem because obviously KNN does not have a training phase because they are just memorizing the training data set. And as algorithm, as data set grows, the algorithms decline very fast. Their accuracy will decline it because every time they have to compare it to the distance measure, and it cannot tackle any missing values. So that is also one problem. If it suffers from skewed class distributions, meaning if a specific class occurs frequently in the training data set, then it is mostly likely to dominate the majority voting. Okay, for example, if there are, this is a class imbalance problem. If there are one class has many records, so accuracy of KNN deteriorates with high dimensional data. If you have more features, then it will fail miserably. Okay, KNN. Higher dimensionality of data set is a major problem. I mean, if you have let's say 15, 20 features, in that case, KNN will not work well. Okay. So obviously the point 7 says KNN suffers from curse of dimensionality. It means if you have a more data set, then it will not. I mean, if it has a more features, then it will not work well. Okay. So these are the some, you can say, the bad part of this KNN, but if you have a small data set and less number of features, then you can go with this KNN. Okay. Applications of KNN, just quickly, let me go through it. Give me just 2 minutes. So for example, if you have to design the recommender systems and you have to display, let's say, whatever you see in YouTube, okay, or Amazon through your browsing history. So the KNN, they use these distance measures, and then they give you, a set of recommended list of items to be watched. Okay. For example, if you buy a smartphone from Amazon, it recommends a mobile cover also. Okay. So this is one application. On the back side, they use this KNN approach. Application 2 could be, for example, you have to see the financial transactions. Okay. So if you can say retail industry, if they just like to identify the patterns in the credit card usage, if there is some unusual pattern in credit card or fraud detection, in that case also KNN can be used. Okay. Third one is, for example, KNN also find application in politics for classifying a potential voter. For example, typically most of the you can say the politician or political you can say parties, they use this social media data, and they just try to classify whether maybe one constituency is going to vote for them or not. So they just classify the constituency based on, you can say, the KNN approach also, by, so you can say, the social media data. Another one is this image recognitions, and also KNN can be used. Okay, how to recognize image, whether it's maybe building, bicycle, maybe a person. Okay, so these are the some applications of this KNN. Okay, so this is all from my side. Okay. Any questions? Hope I'm audible, and thank you for keeping patience. So let's close. If you have any question, you can ask. Otherwise, we can close. Sweta, are you there?
Any question, anyone? I think, sir, there is no question. Thank you so much, sir.
Okay, thank you. And sorry for this technical
No
glitch.
problem,
So
sir. It's completely fine.
I hope you have enjoyed this session. So I'll upload all the this PPTs and all. So just look
Okay,
through.
thank you, sir.
Okay, thank you for your participation. Thank you so much.